What's up guys, this is Abhinav Chaturvedi and welcome to my channel. On this channel we'll discuss everything related to software engineering and coding in general. Well, a little about me. I'm working as a senior consultant with Calens for the past 9 years. And my prime area of expertise, so to speak, would be deep learning and artificial intelligence. Actually, that's what currently I'm working on right now. I'm working on a product which is basically an ETL based AI backed pipelining application for enterprises. My primary aim through this channel, guys, would be to transfer the knowledge that I've acquired over these last 9 years to you guys for free. Because if you like the content that I'm making on this channel, please consider subscribing. That would actually encourage me to make more such videos in the future. All right. So today we'll be learning about something called as a RabbitMQ, and it's basically a piece of software that is used primarily in the industry to mediate data interchange between different web services, right? So without wasting any more further time, guys, let's begin. So RabbitMQ is what is called as a message broker. It is written in Erlang. It basically works on a protocol called as AMQP, or Advanced Message Queuing Protocol. That's what it's called, right? So what is a message broker, you might ask, right? Well, a message broker is essentially a software that enables different web services or web components to communicate with each other asynchronously, right? And exchange data. This helps them, or rather your architecture, to reduce coupling and increase scalability, which is quite essential, guys, in a distributed architecture. So how does basically a RabbitMQ or a message broker basically work? Well, simply put, a message broker is basically responsible for mediating message passing between two parties. And we look at a complete example of a message interchange between a producer and a consumer later in this video. We'll be implementing it in Python, so we'll look at it a little later. But basically RabbitMQ has quite a lot of components to ensure sort of reliable message passing from the producer to the consumer, right? So we'll look at few of those components today. The first component which we'll look at is called a producer. Basically what a producer is, as the name suggests, producer is someone who has the data or produces the data that needs to be consumed. What I mean by that is, from an analogy which I can throw at you guys so that you might understand it better, is that suppose you have a web component or a web service, and it's client facing web service, so it gets a request from the client, and the kind of requests it gets are heavy requests, right? So suppose it's a service that needs to do some computation in the backend, which is quite resource intensive, right? So since this service is front end facing, we would not want to do computation on that machine itself, right, where the service is hosted. So there what happens is that service becomes a producer. It gets that request from your UI. So that service is a producer, and it sends that request through RabbitMQ to one of the many consumers that it's connected to. Those and that is obviously an asynchronous call, right? It pushes the data to the RabbitMQ and then forgets about it, and it's ready to get new requests from the UI. In the meanwhile, one of the consumer picks up the request, does some processing on that request, does some computations, and spits out the result. So this is kind of a scenario or kind of a use case where something like a RabbitMQ, a message broker, really shines, right? So we have a producer, and if we have a producer, we also have a consumer, right? So consumer, as we've discussed, basically consumes the data that the producer sends and acts upon it. Apart from producer and consumer, basically what happens is when a producer pushes the data to RabbitMQ, it's actually pushing the data to something called as an exchange, right? So exchange here is another component in RabbitMQ. So it's the third component which we're discussing about. So the responsibility of an exchange is to route that data or that message which it got from the producer to a queue, which actually the consumers are listening actually on queues, right? So the duty or the responsibility of an exchange is to route that message to a queue so that it gets eventually pushed to a consumer. That's the whole deal. So queues here are actually bound to the exchange by something called as a binding key. That's how the exchange knows which queue to route the data to. And there are some algorithms or some exchange types which are wired internally to decide which queue to send the data to, right? We'll discuss about it. So there are basically 4 kinds of exchanges. There's this first exchange which we'll talk about is a fan out exchange. So a fan out exchange is actually an exchange where the message that it gets or the data that it gets from the producer, it pushes to all the queues that is attached to it, right? As the name suggests, fan out. So it fans them out, it kinds of broadcasts them to all the queues attached to it. Then secondly, there is a direct exchange. So when a producer sends a message to an exchange, it also sends something called as a routing key. A data and a routing key is what an exchange gets. Now in direct exchange, what the exchange does is it matches that routing key with the binding key of the queues that are attached to it. So whenever there is a match, the data gets sent to that particular queue, right? That's how our direct exchange actually works. So guys, this is basically what a message broker is, right? We have 2 services and a broker in the middle. This is how the data flows actually. On your left, there is a producer which has the data, right? It sends the data to an exchange with a routing key, right? The exchange is bound to a queue with a binding key. A bunch of listeners are connected to that queue. Now, if the routing key matches the binding key, in case of a direct exchange, the message is sent to the consumer. That is direct exchange. Then there is another type of exchange called topic exchange. So there is partial matching of routing key with the binding key in case of topic exchange. We can use wildcard matching. It's slightly smarter than a direct exchange and more powerful actually than a direct exchange. Then the last one is a header exchange. Here there are no routing keys to be sent. Instead, a message header is sent along with the data, and that is used to route the message to the queue. So that was a brief introduction about RabbitMQ. We'll be implementing basically, guys, a simple producer and a consumer, and we'll be doing it in Python, and we'll use a client library for RabbitMQ. It's called Pika. So we'll use it for our demo, and let's jump into it. So guys, before we begin with the coding bit, we need a running RabbitMQ server. So rather than using many of the cloud offerings available to us, I recommend using a local instance of RabbitMQ. So I'm not going to install a RabbitMQ server on my machine. I'd rather use a Docker container to do so. So first thing we should do is to start a RabbitMQ container. I have a container actually running on my machine. I have this container running and it's running on TCP port 5672. That's the default port. And this comes with a management UI as well that we can manage our RabbitMQ instance, right? So I have this running, but you can start a RabbitMQ server on your own easily through the docker run command. I'll share all the commands with you on my GitHub along with the code for this demo, right? So now that we have a RabbitMQ server running, let's start. So I'll first fire up my terminal and I'll create a directory. All right, so I'll call it Rabbit demo. Let's set up a virtual environment and install dependencies. So we need Pika as a dependency for our project. So we'll add that. We don't need any development dependencies. So we have our environment set up and running. So let's install our dependencies. Let's install Pika. As you can see, Pika is installed. Right now, let's open our editor. I'll use PyCharm. You can use any editor of your choice. All right, so let's create a new file. Call it producer. Right. So to begin, we'll first import our dependency. So we just have one dependency for our demo. It's Pika. Let's import Pika. Let's start. First, we'll create something called as a connection. So we'll create a connection now. It's a blocking connection, and we need a host name for the RabbitMQ server to connect. So we'll have connection parameters. It's running on localhost, so we have a connection. Now we need to create a channel. So channel is something that is actually used to transmit the data. It's kind of like virtual connections inside the connection, right? So let's create our channel. And now after having created our channel, we'll have to define a queue. So let's declare a queue. I'll name it demo queue. So this step is idempotent, guys. So if a queue does not exist on your RabbitMQ server, this actually creates a queue. But if it does, it uses that queue, right? Now we have a basic setup. We have a connection, we have a channel ready, and we have a queue. So we are ready to publish to our exchange, right? So let's write another function to actually publish test data. I'm using this channel object to actually publish the data to the exchange, right? So we need a dummy data actually. So we create a dictionary so this is our message which we'll send to our exchange. So how we will send it is we'll use our channel object. There's a method called basic publish, and pass the exchange, keep it blank. By default it uses the direct exchange, so we'll use that, and then we'll pass our routing key. So since it's a direct exchange and we only have one queue, we'll pass the queue name so that it matches while routing the data to the queue. And then finally our body, the payload. So guys, when we want to publish the data from a producer on the exchange, we have to convert the data to a string or a byte stream or a buffer. So we'll have to stringify this message. So we'll do it here, right? We'll pass this. Before we are done, it's always good practice to close a connection. So this is it. We are done with our producer. We are ready to publish. But before we do that, let's also write our consumer now, right? So let's create another file. We'll call it consumer. The basic setup is same, guys. You'll have to import Pika and create connection and channels. So let's do that. Actually, let me just copy this. Let me just copy this part till here. Reuse this. Right. Now we are ready to start consuming from RabbitMQ. Right. So our connection is created. Our queue is there. This channel.queue declare only ensures that the queue is there. All right. Now let's. Like there was a basic publish, there's a basic consume, and the basic consume essentially primarily takes two arguments. It has many other arguments, but for our purposes, we'll pass the queue name to it. So our queue name was demo queue, and we register a method to it, right? This method which will register will be triggered when the consumer gets or is pushed the data. It receives the data from the RabbitMQ server, right? So this method gets executed. So let's first create our method. Call it callback. So callback basically takes 4 arguments, guys. We are just interested in the body part of it. So we got the message. Let's register this callback, and we'll acknowledge that we receive the message as soon as we get it, right? So So we're ready to consume. So we'll call the start consuming method. It's a blocking call. The process keeps on listening for new messages. Yeah. So that's it actually for the coding part. We created our producer. It's hardly 23 lines of code. And then a consumer, another 20 lines or so. Right now we are ready to see how this works, right? So let's fire up my terminal now. Let me just let's just first start our consumer. So I have a consumer.py, so let's just run this. So okay, so we are waiting for our messages. Now let us run our producer. All right guys, so as you can see that we received a message. This is the same message we sent from the producer, so we got it on the consumer end. So yeah, it's pretty easy, right? So we have our implementation of a producer and a consumer for RabbitMQ in Python. Quite a simple code, guys, and pretty easy to understand, I would think. Feel free to tell me in the comments if you found it difficult, right? So next, guys, we'll wrap this up. We'll conclude about what we did in this video and what we learned. So what did we learn today? We learned about few of the components of RabbitMQ, which there are a lot of components actually. It's a little bit complicated, to be honest. We learned how to use RabbitMQ in Docker. By the way, guys, as a side note, I would recommend you guys to always use Docker to run services as opposed to installing crap on your machines, because when you're done, you can just Docker RM and forget about it until you need it again. You can again spawn a new container, right? It's quite easy that way. So we did that. Then we implemented a producer in Python, implemented a consumer in Python. And finally, we saw how a hypothetical task executor in its simplistic form implementation works using a RabbitMQ, wherein a producer actually creates tasks and pushes them to RabbitMQ, and a consumer fetches those or gets those tasks and process them. Yeah. So that's it from me, guys. Hope you guys found the video informative. I'm also thinking about making a new video on Redis. So do let me know in the comments if you're interested in that. See you guys in the next video. Happy learning.